And then just like go back to the YouTube thingy and then whatever that is.
Okay, is it working?
Or go to like the live streaming thingy. If it's like,
Wow, that's a long call.
yeah. Okay, so now okay.
So,
Yeah, so like we've connected like now just to show like if the basically I'll just go on the channel to see if like
okay, does it work?
It works.
Okay.
I see you.
Okay, amazing.
Wait, let me see what you're doing.
so like audio, visuals, camera, like we don't really need that.
Okay. Great. Alright, hi everyone. Thank you for joining the Maple 1B workshop. So I'll be presenting today along with James and Orchid, who will be presenting the next few parts. Can we just start off by scanning the QR code just to mark your attendance, even if you're watching this online? And I'll just leave this here. Alright. So how this one's going to work is we're going to have split this up into 5 sections. So we have functions of 2 or more variables, further calculus, further linear algebra, 3D geometry, and programming in Maple. Alright, so I'll start with functions of 2 or more variables. So the first thing that I'd like to sort of establish is that Maple treats expressions and functions differently. So they are 2 separate things, and the way we deal with expressions and the way we deal with functions is also different. So certain things only work with expressions and certain things only work with functions. So it's important to understand the difference between the 2. So with expressions, an expression is basically just a group of symbols, whereas a function is something that maps an input to an output. So I'll start with an example of an expression. So the way we define an expression is you use the colon and then the equal sign. So x squared times y minus x. And it will come up here. That's an example of an expression. And then an example of a function could be f colon equals. So x, y, those are your input variables. And then the arrow, because it's a function, to x squared times y minus x. So these 2 are essentially the same thing, just one is an expression and one is a function. So let's say we wanted to evaluate this function at the point 4, 2. For the function, you can just type f bracket 4, 2, and it'll give you 28, which is the answer. But if I was to try to do that with the expression, so e bracket 4, 2, it doesn't work. It kind of gets confused, and that's because you can't treat an expression in the same way that you treat a function. So for the expression, what you would do instead is you'd use the subs function. So subs, so we're substituting x equals 4 and y equals 2 into e. And then you'll get the same answer, which is 28. Alright, so next is partial differentiations of expressions. So the way that we differentiate expressions and the way that we differentiate functions is also different. So with expressions, the way that we can differentiate them is by using the diff function. So for example, if we wanted to diff this expression over here, we can say diff bracket e, because that's what we're deriving, and then in terms of what, so in terms of x, it can be like that. And then as you can see, it's differentiated the expression over here in terms of x. And if I wanted to get the second derivative, you can just type in x again, and that's a second derivative, and then the third one would be 0. But a shortcut for this would be, instead of typing x 3 times, you can do x $3, and you get the same thing. Yeah, and then after you've differentiated it, let's say you differentiated it once in terms of x, you get this, and you want to substitute or find a value at a certain point, you can use the subs function again. So subs x equals 1, y equals 2, and you can use this percentage symbol to denote the previous output, so this one. And then it will substitute those values into that. Now, when we talk about deriving functions, it's a little bit different. So we can't use the diff function. Instead, you would use capital D and the square brackets. And in the square brackets, you're going to put a number that tells you which variable you're deriving in terms of. And the number is just like the order of what variable comes first. So for example, if I want to derive this function over here in terms of x is the first variable, so I'll write number 1. So d of 1, and then f is the function that I'm deriving, and then it'll derive it for you there. And if I wanted to derive in terms of y, then I'll just do d2. And you can also find the higher derivative kind of similarly to how you would do the diff function with the expression. So if I wanted to derive in terms of x, it's just number 1. But if I wanted to find the double derivative in terms of x, I'd do 1 comma 1, and that'll derive it again. And then you can do 1 again, and then you get 0. You can also derive it in terms of x and then derive it in terms of y. So with respect to y, sorry. And that would be 1 comma then 2.
What if you do -1? Is it the interval?
-1?
Yeah.
Let me try it out. No. So I think if you want to integrate something, then you use the int function.
Okay.
Yeah. Alright, okay. And then from there, if you want to evaluate one of these at a certain point, all you do is you just put in brackets the point you want to evaluate it at. So for example, if I want to evaluate it at x equals 4 and y equals 2, just put that in brackets like that, and then it'll evaluate that at that point. You can also find the maxima and minima on Maple, and that's just using the maximize and minimize functions. Just keep in mind that you have to use a Z and not an S because it's American spelling. So, for example, if I want to minimize this function over here, so sine x plus cos cos 2y, you can just type it in the minimize function and then comma, and you can also type in bounds that you want to include, so between x equals to negative pi and pi. So the way you write that is negative and then capital P pi, and then you do dot dot pi again, so that just means it's between negative pi and positive pi, and then define the same for y, so y equals negative pi dot dot pi. Yep. And then that will tell you the minimum value in that range. And then similarly, you can do the same for the max, so maximize, and that's positive 2. Cool. You can also use the plot 3D function if you want to like visualize like a multivariate function. So the way you can do that is plot 3D, and for example, if so you just type whatever you want to plot. So for example, we're doing e to the power of negative x squared times cos x plus y. You just type what you're trying to visualize, and then comma, and then you can put your bounds, but I'll just start with this. So that's what that would look like. You can also like use your cursor to like move it around and like see it. But that's like the whole function, and if you want to view it within like a certain bound, you put comma, and then the same thing as before, so x equals to negative 3 dot dot 3, y equals to negative 3 dot dot 3, and then that'll just give you a section of the graph, so in those bounds that you inputted. Alright, you can also enter like a set of expressions if you want to like graph multiple things on one set of axes. So the way you can do that is using the square brackets. So you put the square brackets where the first expression is, and then you just put a comma and you add your second expression. So for example, sine x plus y is my second expression. And then that'll plot this two graphs on the same set of axes. Yeah, I'm just gonna get rid of this. Alright. Cool. So that's it for the first section, which was the functions of two or more variables. I'm just gonna clear up some space. Okay, now for further calculus. So sometimes when we integrate, it's a lot easier to do the integration if it's split up into partial fractions. So Maple has a function called convert, where you can convert things, and one of the features is you can convert something into partial fractions. So for example, type convert 1 over x squared minus 4, and you'd put comma, and par frac is the function that converts it to a partial fraction, and then comma x because you're doing it with respect to x, and then it'll just convert that function into a partial fraction, and that makes it much easier to integrate. So integrate percentage sign, which means the previous output with respect to x, and that'll integrate that. You can also use Maple to solve differential equations. So for example, if you have a diff equation y dash plus y equals cos x plus x, what you would do is you'd first define the ODE. So we'll call this one ODE1. Then you use the colon equal sign. The thing to remember with this one is y dash and y are functions and not variables, so you have to use y of x instead of just y when you define it. So you would put, so y dash would be diff, so the derivative of y of x, and then you put comma x because it's with respect to x, then plus y, so plus y of x equals to cos x plus x. Cool, so that's defined ODE1. Then to solve the differential equation, you just use the dsolve function. So dsolve, and then what you're actually solving, which is ODE1, and what you're solving it for, which is y of x. And then it'll solve the function for you. You can notice that there are constants in this. So the way you would find a singular solution would be through obviously entering an initial value, which I'll show in a bit. Yeah, you can also use the same process to like define higher order differential equations. So you can have like y double dash as well. It's a similar thing, but the difference would be that when you do the diff y x with respect to x, you just put a comma and put another x, which means instead of differentiating it once with respect to x, you differentiate it twice with respect to x. And then it becomes d squared over dx squared. Yeah, so that's basically the same thing. Now, for initial conditions, so as you can see in the first one, we still have a constant here. The answer is like a family of functions rather than a singular function. So the way that we can get one straight solution is by entering an initial condition. And the way that we do that is in the dsolve function, you put curly brackets where you have the thing that you're solving for, so the ODE1. And then what you want to do is put a comma and put your initial condition. So for example, if I have y0 is equal to 0, I just put that there. And as you can see, that should enter the initial condition into the solve function. Okay. You can also enter initial conditions that involve derivatives. So for example, if you want to enter an initial condition that is like y dash of 0 is equal to 1, the way that you would enter that is using the notation that we did with functions. So capital D, so you just put a comma if you have more than one condition. So capital D of y, and sorry, capital D of y of 0, because that's what you're subbing in, is equal to 1. That would be my second condition. And then there you go, you can see that you no longer have constants in the answer because you've entered 2 initial conditions to solve for the 2 constants. Alright, so you can also use Maple to find the limit of sequences and series. So let's say, for example, you wanted to find the limit of the sum of the reciprocal of 2 to the power of n. So for example, 2 to the power of 0 plus 2 to the power of 1 plus, 1 over 2 to the power of 0 plus 1 over 2 to the power of 1 all the way to 2 to the power of infinity. What you want to do for this is you first want to find a closed form version of the sum. So the way you do that is the sum function of 1 over 2 to the power of k. And you define what k can be between. So comma, k is equal to 0 all the way to n. So by doing that, you get this, which is like a closed form version of the sum. And now you can actually find the limit. So you use the limit function. And percentage is the output of the previous code. And comma, and then you put what n is going to. So n equals infinity. And then you can see the limit as n equals infinity is just 2 for this one. Alright. You can also use Maple to find Taylor series. So the way you do that is using the Taylor function. So Taylor. So for example, if you wanted to find a Taylor series for e to the power of x, starting from 0 with 5 terms, the way you do that is Taylor and then x, comma, x equals to 0 because that's what we're starting from, and then 5 because there's 5 terms, or you want 5 terms. And then you'll get this, so 1 plus x squared, all the way up to x to the power of 4, and then you have this last term over here, which is x to the power of 5. What that is, it's basically just condensing the infinite series into that error term. So if you wanted to convert this into like a polynomial, what you do is you just use the convert function. So convert, and the previous output, and you use the function polynom, and that'll convert that into a polynomial. So that no longer has the o at the end, so it's just a polynomial now ending with x to the power of 4. Alright. Yep, that's it for the first 2 sections. So Orchid will take over for further linear algebra.
Okay, so for linear algebra, in linear algebra we work with a lot of vectors, a lot of scalars, etc. And an important part of that in Maple is knowing how to actually utilize Maple to kind of figure out how you work around vectors. So we start off with a basic summary. So there's a lot of basic operators we use not even just for vectors, but for everything else, such as the plus sign for addition, the minus sign for subtraction, etc. So that can also be reflected within Maple for vectors. So let's say we let v be this be a vector of 1, 2, 3. There we go. And let's say we wanted to scale it by 2. So instead of doing something else, we would just use the asterisk, and that would scale the v into 2, 4, and 6. Furthermore, we can also add vectors. So let's w be another vector of 4, 5, and 6. And to add those two, quite simple, it's just v plus w, and then that should give us that. And similarly, we can also multiply vectors. Oh, okay. Oh, I know. Oh,
Oh, there we go.
right.
Okay, I think we're good.
I think we're good. I think we're good. Oh, that's not good. That's not good. That's not good.
Oopsies. Let's
Sorry, guys.
Is the stream still on?
Check. Is the stream still on?
Oh, it's still good.
It's still on? Okay.
Still on.
That's alright.
Do we even have any live users? Is it just James?
I think it was just James and me initially. And then it kept skyrocketing. It kept going to 4, and then it went back to 2, and then 4, and then it went back to 2.
Yeah, I
So,
just kept occasionally checking every now and then as well.
yeah. But then my other theory was it's just Marie and Owen trolling.
Oh, which support?
Bro, why can't I do this?
Press the download button to get like the video version.
Yeah, just do it. Yep, download.
Yeah,
Then
sorry
just open
guys.
it.
Okay, there we go. Surely that's better.
Yay. Alright, okay. And then we're gonna scoot all the way back down to further linear algebra.
Wait, what?
Okay. Where were we? Yes, multiplying vectors. So that was pretty simple. And now, there's a lot more examples that are here in the sense that Maple just kind of simplifies a lot of the vector manipulation. So instead of having to brute force doing them by hand, you can just use Maple. So for example, cross product of V and W also work like that. Oh, whoopsies. Yay. Oh. Oh no. Is there something I'm doing that's wrong?
Okay, so I have this. Okay, this is my laptop problem. But like, if you go in like, sorry,
No.
if you go into like the bottom,
Yeah, it's not showing.
like this corner, it turns off.
Oh, okay, got it.
So just don't go in that corner.
Alright, can I quickly like, because I can't see what I'm typing here. Is that what you were doing as well?
Oh, you can't see.
Like down there.
Okay, when they finish,
Oh, what the?
you
Just
press
like
the-
delete stuff, I guess.
And there's like
I don't
also.
know why it's doing that.
Is there any way we could like just? Okay, brilliant.
Just.
Okay.
I don't know why it's flipping that. I don't know.
What's wrong?
Okay, like, we'll probably, so if you like go back to the, like the OBS, we'll probably like refresh the, like delete the screen. Yeah, because see right now it's like kind of like broken. Like,
Yeah.
yeah.
Kinda.
So all you gotta do is like just delete the screen and then just re-add it, and then like it will just fix itself.
How do-
Cause that just like,
What's
it just-
broken?
cause like this is like,
Oh, this is frozen.
yeah, it's like frozen. It always happens.
Hmm.
I don't know why.
Oh yeah, it's.
Do we
still
delete
the-
and add it again? How do we add?
Yeah, it's easy.
No, wait, that's already there. Browser. Screen capture. Okay, that's better. I think. Sorry about my computer.
Wait, surely you scale the screen.
Wait, go back to OBS because I think it was only like half of the like this thing.
Yeah.
Oh, yeah, I didn't see that.
Yeah. Or like anyway, yeah, just keep it on.
Full? Like nah.
I mean, you can.
You can move your
you
face.
Can you can change the like the sources like
Order,
so
yeah.
Okay.
you take gravity or whatever.
Oh, okay. Alright. Okay. Brilliant. Alright. We're back, guys.
They should work.
Wait, okay. Oh, that's the wrong citrix. Ah.
Was the issue like? Is it okay?
Yeah, but it's not like.
Okay.
If you go in the corner,
Okay, anyways, moving on. I will quickly rewrite the initial two vectors that we had initially. So this was 1, 2, 3. This is W, 5, 6. And For us to actually utilize cross product and dot product and determinant and matrix inverse, we have to actually load the linear algebra pack. So to do that, we can do with linear algebra. And that loads a lot of things. We can ignore that, but let's go all the way down. So, for example, we want to use cross product, and then we can do VW, and that should give us the cross product easily. Similar to the dot product, VW. So that should be that. So another one is, hold on. Advisha. Your laptop's low-key hard tweaking out again.
What is this?
I don't know.
You don't have like a live audience with like physical people.
I think your laptop hates me.
What is going on? What is it?
Oh no, it's like, how do I make it go back out there? Because is it just showing like half of the OBS in the stream?
Isn't that just the library?
Yeah, why is it doing that? Oh,
Oh, so she can't reach like the bottom. Oh.
yeah, I don't know what's going on with the bottom thing.
Yeah, I also can't see what I'm typing, so I'm praying that it is actually the correct thing.
Maybe it's like,
Oh, that is.
oh my god.
Sorry, audience.
Sorry, audience, yes. Sorry, James.
I swear my laptop's not usually this.
That's alright, that's alright. Okay, surely leave
I
like
think you can
this.
see the bottom now.
Yeah.
Okay.
Okay, boom. Alright. Continuing on. Let's also just let U be a square matrix because we can only use a square matrix to find determinants and inverse. So 3, 4. And let's find the determinant. And to do that, we type determinant and U, as well as matrix inverse of U. So boom. Furthermore, there's a lot more other things that we can find out, like such as the matrix properties with Maple. So there's a lot of it. For example, we can find the dimensions, we can find the rank, we can find the nullity, etc. So I'll only go through a couple of these examples, but we've already loaded it. So let's let A equal 1, 2, 3, 4, 5, 6, and 7, 8, 9. And let's say we wanted to find the dimension, and to do that, and then it should technically give us 3, 3, as it's a 3 by 3 matrix. Let's also have a look at rank, and that should give us 2, because when we actually do reduce row echelon form and examine A, there's only 2 pivot columns, so that means the rank is 2. And furthermore, there's a lot of other things such as null space, where it gives us that vector. And yeah, moving on, there's also a couple other ones such as Gaussian elimination, reduced row echelon form, which I just used earlier, and linear solve. And this, just like I mentioned earlier, is just us simplifying the process and kind of replacing the need to brute force vectors by hand. So I'll just do Gaussian elimination. Let's A be, let's do that, hold on, 10. And let's go with Gaussian elimination of A. That should give us that. And if we wanted to find reduced row echelon form, well, it's the same as here. So let me just copy that. Oh, wait, this is a MacBook, it's not Control. And there we go. We can also solve equations with matrices, and how we do that is with linear solve. And for example, we've let A be that. Let's let B equal to another vector of 1, 2, 6. And to linearly solve, we can use the linear solve function. So we can do linear solve A, B. And what that does is really just augment B onto A and further, etc. and solving it linearly. We also have eigenvalues and eigenvectors. So we can find eigenvalues and eigenvectors using Maple, such as through the different functions such as eigenvalues B and eigenvectors B. So we've already loaded the linear algebra package initially. So now we can just type eigenvalues let's say, let's start another vector of 0, 0, 1, 0, 1, 0, and 1, 0, 0. And we can find the eigenvalues of this as well as the vectors through the eigenvalue function. So there we go, as well as eigenvectors. Onto 3D geometry. Currently in our if you're currently doing Math 1, 2, 3, 1, we haven't necessarily touched on 3D geometry yet, but this is a little insight into it. So we've mentioned earlier of dot product and cross product, and this is kind of a summary of that. But an addition on that is actually using the norm function, and that is basically finding the norm, the magnitude of a specific vector. So let's let u equal to 1, 2, and 3. And to find the magnitude of that, we can use the norm function. And then we put 2. And the reason why we put 2 is in Maple, the value that comes after u, after the comma, has a certain meaning. So for 2, it just is the square root of 1 squared plus 2 squared plus 3 squared. But if we were to say norm u of 1, that would actually give us the magnitude of 1 plus the magnitude of 2 plus the magnitude of 3. And that is just 6. But we don't want that because we want the magnitude of the vector itself. So we remember to have the 2. Furthermore, for the actual 3D geometry, we have to first load the 3D geometry package called geom3d. So we can do that with the with function of with geom3d. And that gives us this whole mess, but we don't really actually need to know all of them. So the nifty thing about Maple 3D geometry is that it allows us to define a lot of different objects, such as points, lines, planes, spheres, and a lot of other objects. And by actually identifying and defining these, we can then use Maple and use a lot of other functions to find out specific details, etc. So for example, let's first define a point. So let's say we can let point A be 1, 2, 3. And to do that, we use the point function. We establish that we want this point to be called A, and then we follow it up with its relative coordinates, which let's say are going to be 1, 2, and 3. Oh, sorry, wait. Oh, okay. Before that, I previously assigned A as a different matrix initially, so let's quickly do the restart. Then let's load geom3d again. Whoopsies. And then let's assign point A actually. 1, 2, 3. There we go. Now that's A. And if we want to find more details about A, we can use the detail command. So that will allow us to look into what specific thing it is. So, you know, the name of the object is A, and the coordinates are 1, 2, 3. Furthermore, we can also define lines. So for lines, let's say there are multiple ways, first of all, to define a line using the line procedure. So the first one is when we give 2 points, and what Maple will spit back out is, oh, okay, we have these 2 points, and we're just going to run a line through the 2 points. So this is through line AB, and how that works is let's first define a point B as well. So let's say B is, say, 4, 5, 6. And when we do line, and then we use the function line, and then we tell Maple what we want this line to be called. In this case, we want it to be called AB. And then we say we want point A and point B to be the points that the line is going to go through. And that should give us AB. And if you want to quickly examine it, we can use detail, and then we say we want to examine AB. And then that gives us the name of the object and the equation of the line. There's also the other way, which is using line L1. So let's say we want to identify line, but we want to call this line instead L1. And this is another method that we can actually use, where we have a look at, let's say, we look at a point, and then we have its specific direction that we want it to go in. So for example, let's say we start from point A, and we also want it to go in the direction of 1, 1, 1. and that's L1. And to look at the details, we can do detail L1, and then we have the equation of the line there as well as the name. Similarly, we can also use the parametric form instead of just the line and the point, or joining 2 points together, and that is through, let's say, let line be L2, and we use its parametric form of 1 plus t, 2 minus 2 times t, and 2t. And we want to establish that t is the parameter. That should give us L2, and to look at the details, we can look at detail L2, and then we have the parameters. And what this basically means in terms of the parametric form is that we want to start at points 1 to 0, because there's no value over there, and we want to go in the direction of 1 to 2. We can also define planes. So to define a plane, similar to the lines where we give 2 points, in terms of planes we give 3 points. So let's say we can do, let's see, because we've already established point A and point B, we can establish point C as, let's do -1, and let's go with 3. And then if we want to find the plane that runs between A, B, and C, we do plane. We say that we want this plane to be called ABC, and then we put the relative points A, B, and C. And that should give us the plane A, B, and C. And to examine it, like always, we use detail. And that should give us the equation and the name. There's also another version of finding the plane, which is using the point and normal form, which is we give, let's say, let's form another plane, and let's say we start from a certain point, let's say C. So we first define that we want this plane to be called P. We are going to start from C, and the normal that we're going to set, that is at the point C, is 1, 1, 1. And that should give us another plane of point C. And once again, looking at the detail, that's the respective equation. The last one is when we use the Cartesian equation to find the plane, or to kind of define the plane actually, where let's say we want this plane to be called P2, and then we're just going to give itself the Cartesian equation of x plus y plus z equals 7. And then we're going to say, oh, we want it to be in the axes of x, y, and z. And that should give us P2, detail P2, and it gives us the following information. Furthermore, we can also define spheres. To define spheres, there's 2 main ways that Maple actually allows us to define spheres. The first way is when we give itself 4 different points. So let's say I'm just going to re-establish point A, B, and C and change them around. So let's say point A is 1, 0, 0. Let's say point B is -1, 0, and 0. Point C is 0, 1, 0. And point E is 0, 0, 1. So to use the sphere function, we go sphere. Let's say we want the sphere to be called S. We put down its relative points here, A, B, C, and E. And then the next part is center name, and we're just establishing that the center of the sphere is going to be called Q. And remember, because Maple, like Ambisha said, is American, we can't spell center with the R-E, and instead it's E-R. And we go center equals Q, and that should give us sphere. And to look at the details of the sphere, we go detail S, and then boom, we have the radius of the sphere as 1, the coordinates of the center as 0, 0, 0, and a lot of other things. The second way of finding the function of a sphere, of defining a sphere, is when we give it 2 points. So for example, let's say sphere, and then let's say we want the sphere to be called S1, and we're going to give it 2 points. And by giving it 2 points, we're saying that these 2 are the endpoints of a diameter, or a point and a number. So the first way is of the endpoints of a diameter. So let's say A and C are the endpoints of the diameter, so A and C. And that will give us S1, detail S1, and then because it's between, let's see, what was it between again? It was between 1, 0, 0 and 0, 1, 0, then the center would be half, half, and 0. There's also the other version where we give a point and following it is a number, and Maple just assumes that to be the center point as well as the radius. So we can do sphere equals S2, and we can give the point. So let's say we want A to be the point, or to be the center, and we want the radius to be 4, and that would give us that. And S2, let's look at the details of S2, and boom, there we go. We have the centers at 1, 0, 0, which is point A, and the radius of 4. Maple can also define some other objects such as segments, where we define a segment as a finite line between 2 points instead of the normal line where it passes through 2 points. It ends at 2 different points. So let's say to define this segment, we can first, let's define a point x, where x has the coordinates of 0, 2, and 0. And to find the segment of A and x, where A is 1, 0, 0 from what we previously assigned, we do the segment, and let's say we call this segment AX. And then we want the first point to be A and the second point to be X. And this is the segment. And to be pedantic, let's do detail AX. And we can see that the initial and end points of this segment are 1, 0, 0 and 0, 2, 0, which is A and X. And furthermore, we can also define a triangle in Maple. And how that works is we use the triangle function. And then we say we want this triangle to be named T. And we're going to give it its 3 points / vertices. So we do A, X, and C, where A, X, and C are defined points. We do T. And then when we look at the details of T, we know that, 3 vertices are 1, 0, 0, 0, 2, 0, and 0, 1, 0, which correspond with A, X, and C. Now, my other subcom member, James, is going to come up and present object information.
Hello, I'm James, and I'm going to be taking you all through the next part of the workshop, which is the second half of 3D geometry. We'll start with object information. And ORCID before has already covered most of this. The first command we have used so far was detail, and that pretty much gives a brief summary of like the name, the form, as you can see here, radius for the sphere, surface area, volume, and equation. There's also a few shortcuts we can use instead of having detail. So for example, we had this sphere S2. We can actually instead just get the equation directly by typing in equation S2. And then in terms of x, y, and z as the parameters. So that just gets us that equation very quickly without all the other clutter that we didn't need from before. And say we also want the coordinates of a point. That's pretty straightforward. You just use the coordinates command, and let's say we want to find the coordinates of the point A from before, and yes, we just get it in this form, vector form. Now on to the next part. So intersections is quite useful. You might end up using it in your exam or lab test, and while you might think that intersections actually just straight up gives you the point of intersection, it actually gives an object, but it's also quite straightforward to use. So let's say we want the intersection of one of the lines earlier. Actually, I'll just make a new object. So let's just say line AB, and let's have the start point A and end point B. Okay, and let's say we want the distance between AB and the intersection, between the plane P1 from before and this line AB. So what we have to do is type in intersection. We call the point of intersection, let's just call it G for the name, and then AB for the line, and then P for the plane we made earlier. And that's G. see that it results in an object. To actually find the information about the intersection, we just need to type in detail. Very useful command, and then that gives us the coordinates of the intersection, 3, 0, 0. So very easy to use, and then when we actually want to plot these 3D geometric objects, we just use the draw command, which is a bit different from the plot 3D, but this is the draw command is actually just for the geometric objects. So to use it, we don't need to declare any of these. We can actually, I'll just use the geometric objects we've made previously. So let's just say draw. All we have to do is put curly braces as well, and then let's say we want to draw the line AB, put in the sphere as well, and then let's put the plane P as well. Okay, and then here we go. We have a sphere, we have a line, and a very small plane on this side. And to actually look at it, you can just scroll. On the right, there's also a context menu. You can adjust the visuals there, transparency, glossiness, orientation. But most of the time you won't need it, since the whole purpose of plotting this out is just to take a very general look at what the geometric objects look like. Okay, so let's go down. One thing you might want to do though is adjust the color. So that just makes it the contrast a bit higher. Might be easier to interpret, but probably won't need to use that. But I'll just show you anyways. So for example, we can color this equal red for the line. Let's just say the color equals pink for the sphere, and then color equals blue. And then once we run that just adjusts the color for all of the shapes. So we got red line, we got the blue plane, and then we got the pink sphere. And some other useful properties are the find angle and distance. So find angle, that gives us the angle in radians. This can also be used for other objects, but it has to make sense obviously, such as like a plane with a plane. That can sometimes be done. And distance, you can use it between 2 points or 2 parallel lines when it makes sense obviously. So don't be surprised when there is an error if you try find the distance between like a sphere and say this line, because it keeps intersecting. Okay, so let's just go with finding the angle between the plane from earlier and then AB. And then as you can see, it gives us the angle in radians. So quite useful there. And then let's use the distance function now, and let's just do between 2 points from earlier, AC, and there we go. So pretty self-explanatory. So on to the next section is actual programming in Maple. So what's the purpose of doing programming is to pretty much break down like complex questions that have multiple parts by using like loops, conditional statements, and procedures. Or if you have lots of repetitive tasks and you just want to use the same block of code to find the answers or get a result that you don't want to type in like 20, 30 lines to get. And yeah, so we can evaluate long expressions, which normally are quite tedious. And because they're built into Maple, you don't need to roll in any unnecessary functions. So I'll clear up everything here, and then just restart all that so we can start anew. Okay, so first of all, when we actually do programming, and Visha's already introduced us to the functions, so to actually declare or initialize them, you just use the assignment operator, and then we want the function with x, and then let's just make it a doubling function. So that completely works, and to actually use it, you can just put x as 2, and it'll give us 4. So pretty intuitive. And then what the purpose of procedures is that it's a series of actions. So the function here, suppose we want to make it multi-line, we want to have if statements, for loops, then we actually want to use procedures so it can actually have that sort of structure to have multiple lines. Okay, but in terms of how it actually works, it just works the same as a function as well though. So suppose we do the same thing, proc x is short for the procedure, and then we don't use the arrow, we just put in 2 times x, and then this is the important part. We always want to end proc, because otherwise Maple won't know that we're going to finish up with the multiple lines. But because this is just single line, we'll just end it here. And if we run it just like before, then it works the same. So procedures, the advantage of defining functions as procedures is that it allows us to perform multiple actions. So we've already mentioned that. So for example here, suppose if you want to double a number, square and add 1, then we can just use the procedure here. So we already have this doubling function, but we'll get into more of how to use this over multiple lines later on the slides. Okay, so before we get into any more extensive programming, we want to introduce another data type, which is booleans. And to actually use them, we can use eval b. So this can be helpful to find true values of complicated expressions, equations, anything that you just want like a quick check of. It's like a Casio calculator when you go into the true or false mode. So let's just say we assign x equals 6, and then if we want to do a quick check, if it's greater than 3, how it works? True. Simple as that. But if we want to use like a more complicated expression, then we can say eval b 100x minus 99x minus 98x. We can see from first glance this would be definitely false, but if you're going to use a more complicated expression, then this would be very helpful. Okay, and conditional statements. So sometimes we want Maple to make decisions, and to do that we use conditionals, and that's either with if statements, else if statements. And to actually use it, the syntax is really straightforward. You pretty much use if and then followed by the condition, and you put then, and then below that line you can actually put whatever you want to do in the inputs, and then once you finish with that condition you just write end if on the next line. So let's explore a program where we actually use this. So let's say we want to find the circumference of when we're given the radius. So first of all we have to set up the proc, the procedure, and what we want to do, name the procedure, and then use the same syntax. And importantly from here, because we don't want to end the line quickly, we want to press shift enter, not enter, because if we press enter then it just finishes straight up. We want to press shift enter so that it continues, we can continue writing the procedure. Okay, and then also you should use semicolons when you're finishing like an action. So after this, then we just put semicolon after the procedure, and then if statement, where we're going to use the conditional, and then we put the condition here. So if the radius is negative, then we go into this statement, and then we put our then here. Okay, and then shift enter again, and then we put what we want to do with what we want to do once we get to this condition. So we're going to output an error and throw the error negative radius. And we don't use a semicolon on this line because we haven't finished with this action, but once we end it, end if, then we can do the semicolon. So as you can see the structure here, you put the if, then you put the condition, and then you do the then, and then you can put whatever action you want to do. Once you get into the condition, you can put more lines if you want to extend this program, but we're just checking if it's negative, so we don't need to do much. And then after this, we can just we've done our check. It's not negative. It's not. It is. If it is negative, then we'll throw the error. But if it's not negative, then we can just evaluate the circumference. So eval f, eval function, and then importantly at the end, we also want to end proc. See, there's a pattern whenever we use like proc, when we use if, we always have to end it once it's done. That's just signaling to Maple that we're finished with this part of the program. And then once we finish the procedure, then we just do end proc. Okay, and you can see that it works. So all we have to do is type the actual procedure, and then let's just put in 2, and we get 12.566 for circumference. So say if you have a question in the exam that you need to use circumference a lot, then you can write a very short program to actually find that. Okay, next part, loops. So loops are pretty helpful for when you have lots of repetitive tasks. Say you have like the same data type, you want to apply some sort of action on it multiple times and get a result or answer. And loops are pretty straightforward and simple to use for these situations. And the general syntax for a loop is, first want to begin with for, and then I, which is the starting point from starting point, and then by, which is how much we want to increment it or increase it by, and then to the end point where we want to finish the loop. And then after that, we also have to include do. If you're familiar with coding, then normally you don't put a do, but in Maple, it is kind of interesting. They do require do before you actually perform the action. And then once you finish whatever you do, then you do end do. That's a lot of do's in the sentence. Okay. And then let's go for an example. So we want to find the sum of the squares from 2 to 20. What we could do is first, let's just assign total equals 0. Okay, looks like I forgot to shift enter. And then let's start our loop. So if you're not familiar with coding, then what this does is for I, that just starts from 2, and then we increment it by 1. So that's going to be going from 2, 3, 4 until our endpoint, which we'll set it as 12. And then we do. Okay, looks like I forgot to put a semicolon here, so we can just put that there. And after that, we can put our actual action for the loop. So while the loop is running, we want it to keep increasing total by I squared. Okay, and then once that's done, you can do end do. Similar pattern to like end if, end proc. Whenever you use these types of like for loops or if statements, then you always want to end them. Okay, and let's see how that goes when you run it. So as you can see, it adds up 2 squared, adds up 3 squared, 4 squared, 5 squared, and then you can get your end result, which is 649. And we'll go through another practice problem, just to go through like how you can apply this in actual questions. So suppose we have a set of prime numbers 2, 3, 5, 7, 11, 13, and what if we want to evaluate the sum of these primes squared? Normally you would use sigma notation for things like this, but because there isn't like a consistent pattern between the primes, like we can't just express it within the summation because all of these primes are different, we can actually use loops. So the first thing we want to do is set the list of primes. So what we do is use the assignment operator, call it primes, put the prime numbers in. So we go up to 13, and then semicolon there, set total equals 0, and then we'll make another for loop. So for p in prime, so what it's telling is iterate over the prime. So we'll go from 2, 3, 5, 7, and we put the do as well. Every time we iterate over the primes, we increase total by total plus b squared. And then, okay, looks like I forgot to end do. Once that's done, then you can see it's just like before. It shows us the result of total after we iterate through the loop each time. So as you can see, after it iterates through 2, it puts 2 squared, and then that goes to 4. 3 squared adds to 13, and you can see it goes up to 377. Okay, so let's go through one last example where we put everything all together, pretty much combining all the if statements, the loops, the booleans, and then put it into one program so you know what to do once you get into a question that you find that maybe a program might be appropriate for. So let's say we want to take an input integer n, and it will output the sum of the integers from 1 to n, but if it's negative or 0, then it outputs -1. So what you first want to do is start the procedure. Now, there is something wrong with this sample maple input, and you might wonder why, because it looks okay, but we'll see what happens when you run it. So let's go with assign it to procedure n, and then let's put a semicolon there, and then let's set our total equals 0. And we'll start a conditional statement, so if statement. So if n is less than 0, then we obviously don't want to run the normal actions, but we want to return -1. Put a semicolon there, and then end if. But if it is positive, then we actually want to run the loop and then get the total. So for I from 1 to n, because we want to make the sum from 1 to n, we include our do, and because we don't include by, then Maple will assume that we iterate by 1 each time. So we don't really need by each time, just to make it faster. Okay, so after we do the for, we do the action, and we just want to increment our total by total plus I. And then once that's done, we do end do. Okay, as you can see, this doesn't work. And the first thing that you want to realize is that we actually haven't ended the procedure. So we actually have to end prop. And then we also get this error. And the reason why is because, interestingly, Maple already uses sum as a function that is built into Maple. So that's why we can't name it sum. That's why we should name it something else. So for example, let's name it sum n. And as you can see, that works. So those are some of the errors that you should try to get familiar to. Oopsie. Didn't want to open that. And then once that's working, you can just do sum n, and then let's just say sum from 1 to 15. As you can see, it just gets the sum from 1 to n. And that's pretty much it for our workshop. And please do scan the QR code to fill out the attendance.